Al Pacino in one of his roles, and one to be Vivek Reddy for an hour. So got my dream getting through today. So I'm going to speak on behalf of Vivek. So his topic, as you could see, is the latest technologies in AFib, and the way this is been presented today is focusing on the latest in pulse field ablation technology. So let's start with this slide here. By the way, before I start, how many in the room are electrophysiologists? Raise your hand. How many in the room doesn't do any ablations? Raise your hand. That's a lot. That's good. Okay, so this slide explains to you what we do in the non-EPs in the room. Probably you've seen this multiple times. Is the PVI, or pulmonary vein isolation, is becoming a standard procedures for what we do since, Michel and his group, Melissa's with me here. She was one of the first people in the world to start this concept in Bordeaux in 1998. But PVI is still there. This is the standard procedure, what we do in every patient if we go and ablate AFib. Persistent AFib, the same thing, and we try to look outside the veins and see if we can find something exciting, still looking for that exciting thing. Nevertheless, this is the ablation procedure we do today. These are the catheters, the thermal, as we call them, thermal ablation strategies that we use for years until recently, the only strategies available to us. You see in here, the point-by-point ablation based on catheter with tip, we ablate point by point to isolate the pulmonary veins and more, or the balloon one-shot system, like a balloon, cryo balloon, or here is the cardiofocus laser balloon. So this is what has been approved, the thermal guided ablation. As you know, all of you know, these technologies, RF or the balloons, cryo and the laser, are non-specific, tissue non-specific. They don't discriminate between kind of tissue you ablate. Examples here, and all of us who ablate AFib deal with this every day. We go to lab, how deep our lesions, how safe are the corresponding organs, like the esophagus or the phrenic nerve, like in this example. So that's the dilemma we face every day. We go to the EP lab to ablate AFib until recently as PFA came alive. So non-tissue specific ablation, we ablate the areas where we are, and we're trying to be as safe as possible, as seen in this example. Applies for cryo, applies for cardiofocus and laser, and as well for AFib ablation. So recently, and the pulse field ablation came to life, and that's what's beautiful about this way of delivering energy. As you all probably EPs in the room know, it's a tissue specific. So it's not tissue agnostic, also like seen in this example. So it's cardioselective, a cardiomyocyte selective ablation. Tissue opens the pores of the wall and kills the cell this way. Saves, presumably, and this is what we're hoping long-term and short-term, saves these kind of cells. This is the nerves around the heart, or within the myocardial cells, the smooth cells like the ones for the esophagus, or the vessels, the vessel walls, all kind of smooth cells are usually saved with this ablation. And that was the hope and excitement as we start doing this going in the last years and going forward. So that's an example from the FARAPulse system, the FARAWave catheter, the flower, and you can see here in this example, when you deliver this energy, you save this corresponding, or the neighboring tissue, or the organs like the esophagus, or the nerves, and in this case is the phrenic nerve, compared to the previous slides. So this is some work from Vivek's lab, animal work. You can tell here he tried to ablate on top of the esophagus, SVC and the surrounding tissue, the IVC in this case, and you can tell the esophagus, the esophageal tissue, of the histology showing no lesions whatsoever, despite delivery in the IVC with the PFA. In the contrary, if you look at the RFA lesion or radiofrequency ablation on top of the esophagus, he could go through and cause an ulcer within the esophagus. So you can tell this tissue, these lesions are more cardiomyocyte selective versus RFA, or as well the cryo or the laser. It's not, and this is a case, a beautiful example here, actually from Melissa's lab and Pierre's work in Bordeaux. You can tell cryo versus radiofrequency versus PFA, how the esophagus is clearly protected, while these in these two cases, you can see the lightening here on MRI of the esophagus. That means there's injury, at least there's edema within this area. So this is kind of explain how PFA is in terms of safety, in terms of, at least this catheter here that has been used in these testings. So this is again the Farapulse catheter from Boston Scientific, and this is some work again from the Bordeaux lab. You see the MRI here. This is an edema. We see the same thing. We see a lot of edema within 24 hours. 3 months later, we're not seeing as lesion. There's a lot of structural modeling despite the low voltage areas. Nevertheless, well, the reason I'm showing you is to show you how much lesions with this one-shot system you're causing around the veins, just 4, 5, 6 lesions within the certain vein, and you have this amount of lesion formation on MRI. They can see it acutely. So this is the data that the first study that Vivek put together, and you can tell the PFA versus all patients comparing the outcome, and you can tell we are within 84% success rate at long-term follow-up in terms of suppressing atrial fibrillation. This is one of the first trials that he published a while ago. And if you look at this, is important here because as we go, we learned a lot over the years. And then adjusting this for the waveforms. Waveforms, the way we deliver the energy, when we get using the power and the RF, high power, low power, more temperature, less temperature, and so on, and contact. Here, contact remains to be an issue. We're learning a lot as we go, but more importantly, the type of waveforms we use, as we're learning a lot with time. And this is an example how based on adjusting the waveform in this same catheter, how we improved outcome long-term within 6-7% better outcomes, short-term as well and long-term, sorry. Keep this in mind. There's a lot been done as we go. We're learning more and more in terms of efficacy of this lesion delivery. This is an FDA trial that was done in the United States, and Vivek presented this recently, published in New England Journal of Medicine, the ADVENT trial, comparing the pulse field versus cryo and RF together. There was around 608 patients in the trial, 7 patients in the trial, prospective randomized. And you can tell the data is seen here and listed here. The outcomes are similar. PFA wasn't superior in terms of suppressing 30 seconds of atrial fibrillation recurrence at follow-up. And that's important. So the outcome of the study was efficacy and then inferiority, 30 seconds recurrence of AFib. So, and obviously safety. The results were non-inferiority, but wasn't superior. Now, if you, in 2020, we published a paper from Kassel with Johannes Brachmann. He published the data on the burden, that the burden of AFib, this is the first paper back then to show the importance of AFib burden in terms of outcome after ablation for atrial fibrillation.